So I have some vintage equipment to show you today, and that equipment is two movie cameras. This Eumig C3m regular 8mm, or perhaps more accurately, I should say double 8mm movie camera from the mid-1950s, and this fancy, modern, early to mid-1970s Kodak XL55, where XL stands for existing light. You could actually use this to make a movie in your living room without the need for any movie lights. What an innovation. Now, I have a bit of a story to tell you about these two cameras, and that's because I've actually used both of them. Well, sort of. When I was a little kid, I was rummaging around our home and I came across a box and I discovered a movie camera. I had no idea we had one. And of course I asked my parents, and it turned out my dad had bought a movie camera many years before I was even, well, thought of. And based on some old movie films that I found many years later, as well as looking up this camera on the internet, it looks like this camera was made around 1955 or so, and it was made by Eumig. The name should be on here somewhere. There it is. In Austria. And it is actually a beautiful piece of machining. And it took fabulous movies. And then, shortly after I found this camera, I started using it. I convinced Dad to buy me some film, which wasn't cheap in those days, by the way. A 3-minute roll of film typically cost $5, which probably now is equivalent to 20 or even 25 bucks. Anyway, that was all good and well, and I think Dad was actually quite happy that somebody was now taking movies and recording family stuff. And we went on a little vacation and left the camera in the car, and well, we later found the car with a broken window and no camera, amongst other things. And so that was the end of this beautiful camera. So how come I have it here? Well, I was in a vintage camera store a few years ago, and well, I sure recognized this camera and had to have it. And actually, if you look on places like eBay, you'll see these cameras typically sell for 100 plus or minus 50 bucks or so, and they still work today. In fact, you might be able to hear it if I press the trigger on the back. Anyway, this was a huge disappointment because once you have a movie camera, you never really want to be without one. And so we did some looking, and Dad was actually a diplomat, and he was posted to Bonn in West Germany, and there was a American PX in Bonn that we all went to, and of course they had the latest, greatest stuff from companies like Kodak, and so we got this movie camera, and it was, well, it was sort of the classic thing. We knew we were buying it, we bought it, and it was wrapped up and put under the Christmas tree. And of course, like many people probably that year, when the presents were opened under the Christmas tree, there was this fabulous new movie camera, and movies were made using existing light conditions. And you would have thought that, wow, this fabulous ultra-modern camera would outperform this more classic 1950s camera. Far from the truth, and I'm probably one of the few people who can actually give you a true comparison from back in the day. So, how are these cameras different, you might ask? Well, from a purely manufacturing standpoint, you can see that this wonderful camera is nicely machined, and if I open up the back, You can see virtually everything is metal inside except some plastics, and they are really hard black plastics, not quite backlight, but certainly of that early vintage. And you have to remember that it was really in the 60s that there was the great plastic revolution. Before then, we didn't have nearly as many plastics available as we do now. So it turns out this plastic, even though it is from that period, has lasted very well. And this camera is fully functional. This more modern camera was, of course, made for mass production. It was made way more cheaply so that in true North American fashion, Kodak could crank these out in some manufacturing facility at an enormous pace. And I have a hunch this thing probably cost around $150 back then, but I'm not sure. But I'm sure, relatively speaking, it was way cheaper than this beautiful machined, probably partly hand-built piece of work made in Austria. So that's sort of the difference. Clearly, this was a camera meant for the masses. This was clearly meant for probably a far more select group of individuals that in the 50s would have had the money to be able to afford a piece of equipment like this. However, this runs, and sadly, this camera does not run anymore. And it doesn't run anymore because Kodak used a bunch of plastic cogwheels that were, of course, made from those wonderful new plastics developed in the 1960s. And, well, it turns out those plastics are not quite so wonderful. And it is well known, and you can look this up online, the Kodak XL55 camera, and look for problems or repairs. And it turns out they have a bunch of plastic cogwheels, and over time those cogwheels have failed or disintegrated or what have you. And it was probably because they were from sort of softer plastics that didn't have the longevity that the ones in here did. And they were also used for way more stressful applications, such as being in cogwheels, whereas this thing, well, all the cogwheels would be made from metal. So sadly, I can't even run this anymore. I actually tried a few years ago and was quite disappointed. But having said all of that, that is sort of the manufacturing differences between these two things. Now, how did they run? And again, I did mention this was a huge disappointment. So this good old camera, again, built in the mid-1950s, it didn't have a newfangled zoom, so if you wanted to zoom, what you had to do is rotate the turret and select a different lens. So it had 3 lenses of various degrees of wide angle to telephoto capabilities, and that actually worked pretty well and was pretty solid. And of course, unlike a zoom lens with plastic gears, it still works. But perhaps the best feature about this is it had manual exposure control, manual control of the iris. And the way you controlled the iris was you had a little lever up here so that if you were filming, you could have your finger on the lever and adjust the iris as appropriate. And you might be asking, how did you know what was right or not? Well, somewhere in the bowels of the camera, there is a photocell. And that photocell is used to deflect a galvanometer that you can see when you're looking through the viewfinder. And it basically shows you whether or not the film is correctly exposed. And what the idea was is you would adjust the iris, which was way too stiff a thing for the little bit of power that the photocell produced to move. You would adjust it, and there was this meter that you could see, And if you had the meter centered, you knew you had the exposure about right. And it turned out that worked really well. And the reason it worked so well is one of the problems you have with movie cameras is when you're doing things like panning around, if you're looking at the amount of light that's coming in on the camera, it can vary considerably. And if you have some sort of an automatic exposure method and you have a bright source of light behind you, such as a cloud or a light bulb or the sun, the camera can often get tricked because remember, there was no such thing as AI or sophisticated processing. You just took the average of the light, used that to adjust the iris, and you were done. Now with this thing, you could adjust the light to a good setting. And if you then happen to pan across so that you had some bright light in the background, you simply did not change the iris anymore. And you ended up getting beautifully exposed film. Now, that of course was not good enough for an Instamatic camera. And just like you had Instamatic still picture cameras, this was an Instamatic movie camera. And it also had probably a photoresistor as opposed to a photocell. And because it had batteries in here, there was enough power now that probably by means of some primitive amplifier, the photocell could be used to automatically adjust the iris, and the operator didn't have to worry about anything at all. And that was all good and well until you basically panned from left to right or did something else where there was a significant change in illumination, and you would get wild swings of exposure, often rendering the people you were taking pictures of to become silhouettes and things like that. And this also happened a lot even when you weren't panning and were simply outside and it was a cloudy day, and once again you always got silhouettes. You rarely got perfectly exposed photographs, or movies I should say, and there really wasn't that much you could do about it. So that was the shortcoming, and we immediately noticed that, and there wasn't really much one could do about it because one certainly in those days was not going to say, well, okay, let's try another movie camera. And without the internet to look up things, one didn't really know why. So that was a disappointment. It did not stop us from using it. And luckily, because we often lived overseas, we have, as a result of that, lots of family records of where we were. So what other differences were there? Well, on a film sense, this camera used what was known as double 8mm film, or sometimes regular 8. And it was on spools like this, and the spools are actually 16mm wide to hold 16mm film. And in many ways, that was the genius of double 8. They could essentially use standard 16mm film that was used for industrial and commercial applications and feed it through a camera like this and only use the strip of it on one side. And you say, well, what good is that? Well, because what would happen is once you had the film all the way unwound from one spool onto the other, you would then take that spool off, put it down here, and run it through a second time, exposing the other side of the film. So you ended up with one medium length of 16mm film that was exposed once on one side and then on the other side of the 16mm to make a double length 8mm film. And then when you sent it off by processing, which you always did in a prepaid mailer, which was so typical those days, you would get it back, and you would get back a standard 8mm spool of film, because during the developing process, what they would do is in fact cut the film right down the center, splice the two sections together, and other than noticing that splice in the middle, you wouldn't really know that there'd been any funny business with film sizes. Other than, of course, the nuisance of when you're filming, running out of film halfway into the actual amount of film available. And that was actually maybe a bigger concern than you would think, because these films were typically about 3 minutes long. So it certainly wasn't like today when we have cell phones that can record for 15 minutes, half an hour, all really just depending on how much battery you have and how big your SD card is. So that was how the film worked in this camera. This camera, being of the Instamatic era, Super 8mm film came in a rectangular cartridge, and you just shoved it in and closed it up, and you could film all you want for 3 minutes or so, and then you pulled out the cartridge, put in another cartridge, and you were up and running again. So way simpler, way more convenient, no film threading or anything like that. So that actually worked really nicely. One more subtle difference is the fact that 8mm, regular 888, was pretty much always recorded at 16 frames a second. And in Super 8, that was upped to 18 frames a second. And I've done a bit of research, and I can't really figure out why. Other than probably somewhere along the line, somebody decided that the motion you get from 8mm was maybe just a little bit too jerky, and it would be better to have a slightly smoother rendition of motion. And that brings us to the next topic, which is how many frames a second do you have to capture to get motion? Well, people have done a lot of research and experimentation of that, and of course practical trials in the early days of film. And basically, if you can do about 12 frames a second, that's enough to trick the eye into seeing motion. If you do less than that, what you do is you see things just as individual images, but 12 frames a second or more, and it pretty much looks like motion as far as the eye and the human brain are concerned. As I said, you can see the difference though with higher frame rates. And when you have very low frame rates, the motion is stuttered maybe. You certainly do see that it is not completely smooth. And the higher the frame rate, the smoother the motion appears, but it all appears like motion. And today, well, for movies that you would see in the theater, one typically uses 24 frames a second, and that's, again, somewhat better than 18. And in fact, the sound versions of these Super 8 cameras also use 24 frames a second. For television, the frame rate is, or was, intimately tied to your power supply frequency. So in North America, where we have a 60 hertz power supply frequency, all the early television systems, black and white, and then NTSC, essentially used a 30 hertz frame rate or a 60 hertz field rate. And the reason for that is because of poor filtering in early TVs. If you had a significantly different field or frame rate from your power supply voltage, what you would get is you'd notice a bar of poorly filtered power scrolling across your television screen. So it was really a very practical reason for choosing those frequencies. In Europe, they did the same thing. They used 25 frames a second or 50 fields a second, 50 half frames a second for PAL and its precursor black and white video. That, of course, was a compromise, because part of the problem is the faster your frame rate is, the more information you have to send. In the case of things like television, you need a wider bandwidth, which takes up more spectrum, which means you can have fewer channels. In the case of film, the higher the frame rate, the faster the film flows through the camera. And so what, of course, that means is it's more expensive. And that's really why 8mm or Super 8 was so popular back in those days. And it was because it used the lower frame rate. The frames themselves were smaller, so you used much less film than, say, 16mm. And again, you saw how expensive film was. You can imagine 16mm being 4 times that, so it really would not have been feasible for home use. What else can we say about that? Oh yes, this camera actually had an innovation regarding the exposure time and the frame rate. So typically in conventional movie cameras, what you pretty much did was close the shutter, leave it closed for half the time. While you did that, you advanced the film to the next position, then you opened the shutter for half the time and took the picture and then closed it and advanced the film and so forth. So you pretty much only had 50% of the time for your shutter to be open, so you only used 50% of the available light. Well, Kodak wanted a camera that would operate in a living room or some such venue without the need for movie lights. And so one of the innovations with this thing is they used a 230-degree shutter, which I'm guessing they had a patent for. And so what it did was it kept the shutter open longer than half the frame rate, so that you got essentially maybe 25–30% more light than you would have gotten with a previous type of camera. The other thing they did is they put this big giant lens on top, and I believe this was an f1.2 lens, a very fast lens, and they offered a film which was Agfachrome 160, a brand new film, a very fast film, and that with the longer percentage of time that the shutter was open and the big giant lens that could collect so much light, well, that really did enable the fact that you could, as a breakthrough in those days, take a movie without the need for anything like movie lights. And that did work very well. What else should we say? I mean, I have the original outfit. This was the box we got it in. And there was even a little brochure. Well, a brochure, this was the owner's manual that sort of started off telling you of all the wonders about it and gave you detailed instructions how you would use this thing. And really a very nice consumer package. And if you look on eBay, you will see there are a gazillion of these things, and they go for probably about 20 bucks, I think, partly because they don't work anymore, and partly because Kodak clearly cranked out so many of these. So that's all good and well. But you might be wondering, well, what does a movie shot from one of these cameras look like? And I'm going to show you that. This is a film of me taken by my dad when Dad was posted to Baghdad. He was a diplomat, and this would have been in the mid-1970s, and we lived there for 3 years, and I had built a go-kart. And, well, here's the video of me driving my go-kart. You can see it's very grainy. That's actually a fault of the film and not of the camera. Unfortunately, we had used Agfachrome film, which was touted as being the finest grained, best color film at the time, certainly in Europe and outside of North America. And I think it actually was. The only thing is, it looks like it has deteriorated significantly compared to some of the other films. And I want to do a video about it, but it looks like what's happened is the grain boundaries in the film has darkened. So it is very grainy, but you can see that even at 18 frames per second, you get a pretty good rendition of motion. Now, you can actually see what 18 frames per second looks like on YouTube other than how well it renders motion, because of course YouTube or any other digital format simply takes whatever frame rate is given and converts it to whatever the frame rate on your monitor is. But that's what 8mm and Super 8 film did look like. Interestingly enough, today there are numerous filmmakers and cinematographers who shoot using vintage 8mm cameras, and there are companies that still make 8mm or Super 8 film, and they do that because they want that slightly different look that you get with a slower frame rate and the graininess of a film. Now, truth be told, you could probably mimic it very well using any of the nonlinear editors that are out there with a bit of image processing. Maybe it won't be quite the same, but I think there also is just sort of a bit of a coolness of using vintage 8mm. So that's the story of these wonderful 8mm cameras, or 8mm and Super 8 cameras. To this day, this camera is by far my favorite. It shot beautiful images. But I have a soft spot for this one as well because I shot far more with this one, and this is the actual one that I used. It was a really neat thing to have. So that's about it. What I want to do next time is I'm going to show you some projectors, and maybe we'll even open one up and show you the trick that is used in all movie projectors to take something like 16 or 18 frames a second and project it so you don't see flicker. Because if you project it at those frame rates, you will see horrible amounts of flicker. So there are a number of tricks that can be used in a projector or a television to remove flicker, which again is completely separate from the perception of motion. See you then.